In section 10 of chapter 2, which is the last section of this chapter, we are going to be doing what we did in section 9, which is exponential functions. The only difference being, now we're going to do multiple transformations at once. This is probably the hardest function to graph up until the point where we get to logarithmic and trigonometric functions. But for the time being, these are the challenge ones. I got two examples I'm going to run through, the red one and the blue one. The red equation reads y equals negative 1/2 times 2 to the power of the quantity x minus 5 quantity plus 8. All right. Since I'm subtracting a 5 next to the x, that affects x-like movement. That affects movement in the left and right direction. So that x minus 5 tells me I'm going to go right 5. The plus 8 at the very end, that tells me vertical movement, up or down. Since it's a positive, that tells me I'm going to go up 8. The base of the exponential is a 2 to the power of. You don't need to say anything about that. You can ignore that. It doesn't stretch, doesn't compress, doesn't do anything. However, the negative 1/2, that is going to do something. In fact, it's going to do two things. The 1/2 is going to compress this thing vertically. Compress vertically by 1/2. So if I compare this to its mother function counterpart, this will be half as tall. But for exponentials, that doesn't really mean much. And the negative is going to flip this thing vertically. Okie doke, time to graph. Here's how I graph these. I go right 5 and I go up 8. Right, 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6, 7, 8. And I mark that with an X. That's the center of the graph. It's just that the function doesn't actually go through the center. I then create my horizontal asymptote. Before I create any dots, I make my horizontal asymptote. Remember, the horizontal asymptote, your line should not touch it. If your line goes through your horizontal asymptote, I'm okay if it touches, but if it obviously goes through that horizontal asymptote, you will be docked points. Horizontal asymptotes, you do not cross. Normally, if there was no stretch or compression, no flipping going on, the very first dot you do for all exponential functions is find your center, go up 1 and draw a dot. So our first dot would normally be right here. However, we're going to cut that height in half, and we're going to flip it. So instead of up 1, it would go to a 1/2, and we're going to go upside down instead. So I'm going to go down 1/2. Next, for those of you that didn't catch on, here's how you graph exponential functions really easily. If you go right 1 from your center, you go up the base of the exponential. So if the base of the exponential is 2, you go right 1 up 2. If it was 3, you'd go right 1 up 3. If it was 5, you'd go right 1 up 5. Why is that? Because if you go right 1, then x is 1. And if the base of the exponential was a 7, then that would turn into 7 to the first power, which is 7. That's why you're always going to go up the base of the exponential, because if you go right 1, that says there's just one of them. However, instead of up 2 in this case, we got to cut that in half. So instead of up 2, it's going to only go up 1, and we're going to flip it vertically, so it's going to go down 1. Here is your next dot. Then we would go right 2 and up 2 to the second power, which is 4, but I got to cut that in half and go down, so I'm going to go down 2. Next, we go right 3, 2 to the third power is 8, cut that in half and go down. We're going to go to 4. The next one will be right 4 up 16, because that's 2 to the fourth power. Cut that in half, you'll get 8, and we're going to go down instead. Right here. And that's enough information for us to graph. There's the graph of the exponential. Problem number 2, I have y equals 2 times 3 raised to the power of the quantity x plus 1 quantity minus 4. The plus 1 tells me I'm going to go left 1. The minus 4 tells me I'm going to go down 4. And that 2 in front that's being multiplied tells me I'm going to stretch this thing vertically by a factor of 2. So it's going to be twice as tall as the parent function. So I'm going to go left 1 down 4. Left 1 down 1, 2, 3, 4. Here is my center. draw my asymptote. Normally, once you find your center, you just go up 1, and this would be your first dot. However, we're stretching this thing by a factor of 2, so we're just going to go up 2 times that amount, which is right here. Next, normally we go right 1 and we would go up 3, but I got to double that. 2 times 3 is 6, so I'm going to go right 1, up 6. These are the only dots that are going to be able to fit on this, which is why exponentials can be tricky, because you typically don't get a whole lot of dots. This is what the exponential function roughly behaves like. What I'm looking for when I grade these, I'm looking for the center marked within the x. I'm looking for the asymptote. I'm looking for the coordinates, and I'm looking for a line that looks like an exponential. You do all of those things, you will get full credit. You miss one of those things or goof on those things, you will not get full credit.